Hello guys, welcome back to our channel. Hope you are liking the series of Java 8 from our channel. So far, we have seen various predefined functional interfaces, their syntaxes, their default and static methods, their chaining, and some of the examples to understand how they can be utilized in our day-to-day life. All these functional interfaces used to deal with either classes or the wrapper classes. But what about primitive types? So Java 8 comes up with a solution to this problem as well. It provides similar variant of functional interfaces for primitive types also. But the question arises, why do we need separate functional interfaces for primitive types? So don't worry, soon you will understand why we need separate functional interfaces for primitive types. But before that, let's have a quick look at what are the primitive types, what are their categories. Let's get familiar with the concept of auto-boxing and auto-unboxing. What are generic types? And lastly, what is the requirement of functional interfaces with primitive data types? So before wasting any time, let's get started. So what are primitive types? Not everything in Java is an object. There is a special group of data types, also known as the primitive types, that can be used quite often in the programming. Primitive types are the most basic data types available within Java language. They represent the simplest kind of data that can be stored and manipulated in a program. Java defines 8 primitive types of data: byte, short, int, long, char, float, double, and boolean. These types are all considered to be primitive because they are not objects and they represents the most basic kind of data that can be manipulated in a Java program. Basically, they serve as the building blocks. Because of these data types are defined in Java by default, they comes up with several operations predefined. You cannot define any new operation for such primitive types. Java determines the size of each primitive type. In Java type system, there are four further categories of primitives. The first one is the integer primitives. The second one is the floating primitives. The third one is the character primitives. And the last one is the Boolean primitives. When it comes to integer primitive, this category includes short, int, long, byte. These primitive data types hold only numeric data. Operation associated with such data types are those of simple arithmetic or of the comparison operations. When it comes to floating primitives, it includes double and float. These primitive data types hold only numeric data with the fraction part. When it comes to character, it includes char data type. These primitive data types can hold characters. Operation associated with such types are those of textual manipulation. However, char can also support arithmetic operations. Boolean primitives. This category includes Boolean, and the value that it can hold is true or false. For performance reasons, the designers of Java language decided to include these primitive types. They aren't considered to be object and they represent the raw value. They are stored directly onto the state. Each primitive type has a fixed size and a predefined range of possible values. For example, the int type is a 32-bit signed integer that can represent any whole number. The character type is the 16-bit unsigned integer that can represent any Unicode character. Then the Boolean type is a 1-bit type that can represent either true or false, and so on. Java determines the size of each primitive. The size does not change from one operating system to another. This is one of the key features of the Java language that makes Java so portable. The primitive types are also commonly referred to as the simplest type. Primitive types are important in Java because they provide the most efficient way to manipulate the data. Since they are not object, they do not require the overhead of the object creation and memory allocation. This makes them faster and more efficient to use than the object types, which make them well suited for many types of the applications. However, primitive types do have some limitations. For example, they do not support the object-oriented features like inheritance and polymorphisms. This means they cannot be extended or customized in the same way we customize the objects. In these cases, where these features are needed, object types must be used. To solve this problem, Java comes up with the concept of wrapper classes. Wrapper classes are the objects responsible for encapsulating the primitive types. Java includes wrapper classes for each of its primitive types, such as for Boolean we have a Boolean wrapper class, then for byte we have a byte wrapper class, for short we have a short wrapper class, for char we have a character wrapper class, for int we have a integer wrapper class, for long we have a long wrapper class, for float we have a float, and for double we have a double wrapper class. These wrapper classes are used to represent the primitive values as objects, which allows them to be used in context where only objects are allowed. Such as when you want to sort any values in the collection, then you can go for the wrapper classes. What are generics? Generics means parameterized types. The idea is to allow the different types to be parameterized to the methods, classes, and interfaces. Using generics, it is possible to create class that work with different data types. In Java, generics are the feature that allows you to create classes, interfaces, and method that can work with different types of data. Generics were added to Java in the version 5.0 and are a very powerful feature as of now. So consider a collection framework classes. We can use the list, set, and map with any of the class or the interface. Now if I want to create a list that holds the number, I'll have to write something like this. Array list of integer list equals to new array list of integer, and this code will compile successfully. But instead if I'll write array list of int list equals to new array list of int, then the code won't compile. So wherever generic type is there, only objects are allowed. We cannot use primitive types with the collections. Now let's talk about the concept of autoboxing and auto-unboxing. So the automatic conversion of primitive data types into its equivalent wrapper type is known as the boxing, and the opposite operation is known as unboxing. So autoboxing is a built-in mechanism in Java for automatically converting the primitive types to and fro from their wrapper classes. So whenever a primitive type is converted to a wrapper object, then it is known as auto boxing. And whenever an wrapper object is converted to the primitive type, then it is known as auto unboxing. For example, consider the following code. int I equals to 42, integer wrapper equals to I. In this code, the value 42 is automatically converted to an integer object when it is assigned to the wrapper variable. This is an example of autoboxing. Unboxing is the opposite of autoboxing. It is the automatic conversion of wrapper class value to its corresponding primitive type value. So consider the example integer wrapper equals to 42, int I equals to wrapper. In this code, the integer object 42 is automatically converted to an int value when it is assigned to a variable I. This is an example of unboxing. Now, coming back to our question, why do we need primitive type functional interfaces? So remember the predicate and other functional interfaces. All these functional interfaces takes object types. That means they take input as the object type, and if they specify the return type, that are also object types. So whenever the value is passed to these functional interfaces, the auto boxing takes place. And whenever the value is returned from this functional interfaces, auto unboxing takes place. This automatic boxing and unboxing can be inefficient and can add overhead to your code. It can also cause problems if you are working with the large collection of primitive values, as in additional object creation and garbage collection can impact the performance. So let's consider an example where we have created a predicate that will check if the number is even or not. So we'll iterate over the int array to see the numbers that are present in that array are even or not. So in this example, 6 times auto boxing and auto unboxing is happening, which can impact the performance of the program. To overcome this problem, primitive functional interfaces were introduced. which can always take primitive type as the input and can return the primitive type as the output. Hence, autoboxing and auto unboxing won't be required, and which can significantly improve the performance of the program. Overall, the main benefit of primitive type functional interfaces is that they allow more concise and efficient code when working with the lambda expression. They makes it easier to write a code that operates on the primitive types and can also help to improve the performance of your application. So this was it for today. I hope now you have got the clarity on why do we need separate functional interfaces for primitive types. In our upcoming videos, we'll see some of the predefined functional interfaces for primitive types. So guys, I hope you like this video. So do like, share and subscribe to our channel. Stay tuned for yet another videos on Java 8. Till then, take care, bye bye and thank you for watching.